Now that we understand the four quantum numbers, let's get some more practice using the quantum numbers and thinking about the first four shells, or the first four energy levels. So we'll start with n is equal to 1. So when n is equal to 1, right, the principal quantum number is equal to 1, we're talking about the first energy level, or the first shell. The angular momentum quantum number depends upon the principal quantum number. And so when n is equal to 1, let's think about the allowed values for L. So L goes from 0, 1, and all the way up to n minus 1. Well, n minus 1, if n is equal to 1, n minus 1, 1 minus 1 is equal to 0. And so that's the only allowed value for the angular momentum quantum number. And we know L is equal to 0 refers to an s orbital. So we're talking about an s orbital here. All right, the next quantum number is the magnetic quantum number, right? So ML. So the magnetic quantum number depends on the angular momentum quantum number, and it goes from negative L to positive L. So if L is equal to 0, we only get one value for the magnetic quantum number. If L is equal to 0, the only possible value we could get is 0. And remember, this tells us the orientation, and so we have only one possible orientation. We have only one s orbital. Right, so there's an s orbital, and there's only one of them here. We know an s orbital is shaped like a sphere, right? So remember, an orbital is the region where you're most likely to find an electron here. So there's a total of one orbital in the first energy level, and you could have gotten that by using n squared. So when n is equal to 1, right, 1 squared is equal to 1. That's the total number of orbitals that you're going to find in the first energy level here. Let's move on to number of electrons in the orbital. So you can fit a maximum of 2 electrons in one orbital. So the fourth quantum number, right? The fourth quantum number says the spin of an electron can either be positive 1/2 or it can be negative 1/2. And so if you have 2 electrons in one orbital, one electron has a spin of positive 1/2 and one electron has a spin of negative 1/2. And so if there's a maximum of 2 electrons in one orbital, we have a maximum of 2 electrons in this one s orbital in the first energy level. And since that's the only orbital in this energy level, or this shell, that's also the total number of electrons in the shell, right? So the total number of electrons is equal to 2. And you could have gotten that using 2n squared. So if n is equal to 1, right, so 1 squared is equal to 1 times 2, which is equal to 2. So that's the first energy level, or the first shell. Let's move on to the second shell. So this is where n is equal to 2. So if n is equal to 2, the principal quantum number is equal to 2. The angular momentum quantum number, right, what are the allowed values? Right? Well, you start with 0, and you go all the way up to n minus 1. So we start with 0. N minus 1, that'd be 2 minus 1, that'd be 1. So we go from 0, and then we go to 1, and then we have to stop. So we have only 2 allowed values for the angular momentum quantum number, right? So if you have a n equal to 2, you get 2 allowed values here. We already talked about what L is equal to 0 means, right? L is equal to 0 refers to an s orbital. Right? And there's one s orbital. So in the second energy level, there's another s orbital. This is different from the s orbital in the first energy level that we just talked about. So there's another s orbital here. It too is shaped like a sphere. All right. And what I drew here is misleading. I drew this as being a little bit smaller than the one before. Remember, when n is equal to 2, you're further away. Your electron is on average further away from your nucleus here. L is equal to 1. Right? So if L is equal to 1, what are the allowed values for the magnetic quantum number? So remember, the magnetic quantum number goes from negative L to positive L. So negative L would be negative 1, right? And then we include 0, and then we go to positive 1. So there are 3 possible values for the magnetic quantum number: 1, 2, 3. The magnetic quantum number told us the orientation, so there are 3 different orientations. Right? And we talked about L is equal to 1 is referring to a p orbital, which is shaped like a dumbbell. So we have 3 different orientations. We have 3 different p orbitals in the second energy level, right? One of them goes along the x-axis, one of them the y, and one of them the z. So we talked about this in the previous video. All right, so a total of 3 p orbitals here. So how many orbitals are there in the second energy level? Well, we have 1 s orbital and 3 p orbitals. So 1 plus 3 gives us 4. We could have done this math, right? N squared. So 2 is n squared, which gives us 4. All right, let's do electrons now. So let's go back to the s orbital here. Remember, there's one orbital, so we can fit a maximum of 2 electrons in one orbital. For the p orbitals, we have 3 p orbitals. So if each p orbital is holding a maximum of 2 electrons, 3 times 2 gives us 6. So we have a total of 8 electrons in the second energy level. So 8 electrons, and we can get that from 2n squared again, right? Because if n is equal to 2, right, square that and you get 4, multiply that by 2 and you get 8. All right, let's go to the third energy level, or the third shell here. So when n is equal to 3, what are the allowed values for the angular momentum quantum number L? So remember, L goes from 0 all the way up to n minus 1. So L goes from 0 all the way to n minus 1. So L is equal to 0, L is equal to 1, and L is equal to 2, because 3 minus 1 is equal to 2. So if we have n is equal to 3, right, we have 3 possible values for L, 0, 1, and 2. We already talked about what L is equal to 0 means, right? L is equal to 0 is an s orbital, right? And there's one of them. L is equal to 1 is a p orbital, and with 3 allowed values for the magnetic quantum number, right, we can have 3 p orbitals in the third energy level. So let's focus in on L is equal to 2. So when L is equal to 2, what are the allowed values for the magnetic quantum number? Well, those go from negative L to positive L. So if L is equal to 2, let me use a different color here. So if L is equal to 2, right, we could go negative 2, negative 1, 0, 1, and 2. So that's a total of 1, 2, 3, 4, 5. 5 values, so 5 different orientations for this orbital. And when L is equal to 2, we call this a d orbital. So 5 different orientations, so 5 d orbitals. So I'm going to write a 5 here. So the total number of orbitals that we have in this energy level, right, that'd be 1 plus 3 plus 5, and so that's 9, which we could have gotten from 3 squared, right? So the total number of orbitals is equal to n squared. If n is equal to 3, 3 squared gives us 9. All right, how many electrons can we fit in each one of those orbitals? Well, let me once again use different color. So the s orbital, we have one of those, so we could fit a maximum of 2 electrons into that s orbital. For the p orbitals in the third energy level, we have 3 of them, so each one of those orbitals could fit a maximum of 2. So 3 times 2 gives us 6. And then we go to the d orbitals. All right, so 5 d orbitals, each one can hold a maximum of 2 electrons. So 5 times 2 gives us 10. So what's the total number of electrons that we can fit in this third shell here? So that'd be 2 plus 6 plus 10. That's 18. All right, and again, we could have used this little formula over here. So 2n squared. So if n is equal to 3, square that, that's 9 times 2. This gives us 18. All right, let's do one more, and before I do that, we already talked about the shape of an s orbital. We talked about the shape of a p orbital. When you get into things like d orbitals, you start to get a little bit complicated, and it's a little bit tricky for me to draw. So I'm not going to attempt to draw all the d orbitals in the 5 different orientations. So let's just move on to n is equal to 4. All right, and so I went ahead and rewrote what we were going for here. All right, so we're going to go for n. So we're going for n is equal to 4 now. N is equal to 4. What are the allowed values for L? So that's 0 all the way up to n minus 1. So L is equal to 0, L is equal to 1, L is equal to 2. And then n minus 1, that's 4 minus 1, that's equal to 3. So that's the last allowed value for L, the angular momentum quantum number. And once again, if you have 4 here, you get 4 allowed values. All right, when L is equal to 0, we said that's an s orbital. And when L is equal to 1, we said that's a p orbital. When L is equal to 2, we called that a d orbital. And when L is equal to 3, we're going to call this an f orbital. And S, P, D, and F come from old nomenclature used in atomic spectroscopy, and so it's not really used anymore. But like the S, I think used to stand for sharp, and so that's where your letters come from here. We use them to think about the orbitals and the different shapes here. So an s orbital shaped like a sphere, we know we have one of those. P orbitals shaped like a dumbbell, we know we have 3 of those. D orbitals, we just talked about the fact that we have 5 of them, right? So 5 different possible values here for the magnetic quantum number. So we have 5 d orbitals in the 4th energy level. And then finally F, right? So an F orbital, when L is equal to 3, what are the allowed values for the magnetic quantum numbers? So ML. So what are the allowed values? Well, they go from negative L to positive L. Right? So if L is equal to 3, let me use a different color. If L is equal to 3, right, we could get negative 3, negative 2, negative 1, 0, 1, 2, and 3. So how many different orbitals are we talking about now? That'd be 1, 2, 3, 4, 5, 6, 7. So 7 F orbitals. All right, in the 4th energy level. All right, maximum number of electrons in the orbital. All right, we have only one. Let me use, what color should I use here? Let's use magenta. So I have one s orbital, all right, maximum 2 electrons, so 2 electrons here. 3 p orbitals, 2 times 3 is 6. 5 d orbitals in the 4th shell or the 4th energy level, so 5 times 2 gives us 10. And then we just talked about F orbitals, which would be way too difficult for me to draw. So you can get some nice pictures of F orbitals online or in your textbook here. So if we have 7 F orbitals, right, 7 times 2 gives us a total of 14. So we could have a maximum of 14 electrons in the F orbitals. All right, what's that total, right? So we add all those up. So 2 plus 6 plus 10 plus 14. Right, that's 32. So there's 32 electrons in the 4th shell, in the 4th energy level. And once again, we could have used our formula here. So 2n squared. So when n is equal to 4, right, we square that and we get 16. Multiply that by 2 and we get 32. And so hopefully this gives you some experience playing with the quantum numbers. So you have to be this is a very useful exercise. So just sit down and think about how the quantum numbers depend on each other, right? So L depends on n, and ML, right, the magnetic quantum number depends on this. And so it's going to allow you to understand the periodic table and electron configurations.